All right, good afternoon, ladies and gentlemen. Welcome to another series of tutorials with me, Aubrey. This is part two of what we started. So we started looking at a tutorial from Mathematical Methods 2. This is Mulungushi University. And basically, this tutorial focuses on limits. All right, so the topic focuses on limit. And if you haven't already, please watch part one, where we gave an introduction what limits are all about. Then in part two, we said we are continuing with limits, but now what we're looking at is there are some limits that are undefined. And we gave scenarios where maybe you have a 0 over 0 as your final answer on your limit. Upon putting in your fraction, you have infinity over 0, 0 to the power 0, any number over 0. This could be 5 over 0, 1 over 0. This is undefined. Infinity times infinity. This is also undefined. So if you get any of these infinity or undefinedness of a limit, there's I would say you need to determine if the undefinedness is removable or not, because you might get a situation where you think the limit is undefined like this, but you can simplify it in such a way that it becomes defined. So whenever you plug in your values, you find that the limit is undefined, you need to do some a bit of I would say mathematical simplification, which is basically algebra, for you to determine if it's removable or unremovable undefinedness. All right, and questions that have the same approach. When you check this question 5 here, when you plug in your value directly, you're going to get 0 over 0. So this is basically undefined. Then we have question number 7 here. When you replace, this is question number 6. When you replace in 7 here, that would be 7 plus 2 plus 3. So this would just be 6 over 0, which is this type of undefinedness right here. Then which one? Number 10, is it 11? This is number 11. When you plug in 4 there, you're going to have a 0 over 0 situation, which is undefined. Then when you plug in a 2 here, you're also going to have 0 over 0, which is undefined. Okay. And here, when you plug in 0 there, you're going to have an undefined situation. So these follow the same procedure. Let me see here. This would be 4 plus 2. That would be 6. This, you're also going to get an undefined. Here, that would be, this is also undefined. It's the same procedure. Okay, that's the same procedure. This is 1 over 0 minus 1 over 0. This is also undefined when you plug in directly. Okay, so basically these are the questions that we are going to look at in this video. So I'll just do one problem and you should be able to do the rest of the problems. Now, if you see, there are two cases of problems here. There is this case where we don't have radicals in them. Radicals, these are the square roots, the cube roots. Okay, you see here we don't have radicals, but it's a quotient. A quotient meaning that we have division. We're dividing this over that. That is a quotient. So a quotient, these are all quotients, as you can see, but there are two types of quotients here. We have quotients that have no radicals, that have no square roots in them or cube roots. Okay, then we have quotients that have cube roots or square roots in them. All right, so the approach for these that have no radicals in them, it is the same approach we'll be doing for all those that have no radicals in them. And the approach for those that have radicals in them, separated by a number, it's the same approach that you'll be doing. Okay, that are quotients. All right, so let's start with question number 5 here. Let me just switch to my whiteboard. All right, so this is number 5. As you can see, I have noticed that there is an error here. So this should be this should be x, since we have x here, x there. So this should be x. So this is how I've written number 5. The limit of this, instead of t, this should be x approaching 5. All right, so this is what we have here. So if you have a quotient here and you check that it is undefined, so for instance, you plug in your values. So that is the first approach, which is the easiest approach. You plug in your values. You have 5 minus 5 over, that will be, when you plug in 5 here, that will be 5 squared minus 25, which will be equal to 0 over 0, because it's 5 minus 5 is 0. This is 5 squared, that is 25. 25 minus 25 will also give you 0, so which is undefined. Okay, so you just say undefined, but you need to undefined, so you just say undefined. Just say undefined, but you need to determine if it has a removable or a non-removable undefinedness. All right, so for all these that have a quotients, all right, that are quotients, they have a numerator and a denominator like that, then there are no radicals there. The approach that you take for these is you just differentiate the numerator and differentiate the the denominator, and you apply the limit again. This is called L'Hopital's rule. So by L'Hopital's rule, so by L'Hopital's rule, we're just taking the limit as x approaches 5. On top, we have x minus 5. So we put in brackets, we put a prime there, showing that we're differentiating with respect to x. At the bottom, also, we say this is x squared minus 25 prime with respect to x. So now this becomes limit as x approaches as x approaches 5. As x approaches 5, then the differentiation of this with respect to x, differentiating with respect to x, that will give you 1. Derivative of x, how we differentiate, we say the power, this is to the power 1, so we subtract 1. So 1 minus 1 will be x to the power 0, which is just 1. The coefficient there is also 1, so that is 1 there. Then the derivative of a constant is 0, so we say plus 0. There's no need to put that. Divide by, so I'm doing this hoping that most of you know how to differentiate. This is a prerequisite for you to do calculus 1. You should know how to differentiate. All right, so we differentiate with respect to x. This will be, we drop the power, which is 2. Then we write x. Then we say 2 minus 1. We subtract 1 there, so that will be just 1. That is how we differentiate, basically. And the derivative of a constant here will be 0, so there is no need to show that. So we have 1 over 2x. Then now we plug in our limit. Let me just... So now we can plug in. That will give you 1 over 2 times 5, which is just equal to 1 over 10 as your answer. All right, so this is what you do for all radicals. For all quotients that don't have radicals. You just, if you find that you have 0 over 0, infinity over infinity, when you get such a scenario, 0 over 0, infinity over infinity, you use L'Hopital's rule. Okay, so for L'Hopital's rule, the type of undefinedness that you should get is when you have 0 over 0, infinity over infinity, You have infinity over infinity. Okay. Yeah, 1 over 0. You can use L'Hopital's rule for this type of undefinedness, and infinity times infinity. Okay, you can use L'Hopital's rule if you have such a scenario. So you're going to use L'Hopital's rule for question number. So we've done 5. We said this should be x. So question number 5, use L'Hopital's. This one, try using L'Hopital's as well. Use L'Hopital's there. Where else? Use L'Hopital's here. Try using L'Hopital's there. Yeah. So these 4 questions, how many? 1, 2, 3, 4, 5. So 5 questions. You're going to use L'Hopital's rule. All right. So if you have any question, you can comment in the comment section below. Now we're going to look at a scenario where we have radicals in the quotients. Okay, so it's a bit different when we have radicals in the quotients. All right, so basically that's it. And there is also another method when we have this, but it also gives the same answer. Okay, where L'Hopital's rule, you are not familiar with L'Hopital's rule, you get the same answer following that. But just use L'Hopital's rule when you have any of those cases of undefinedness. Then now we are going to look at these scenarios. Follow us in part 3.